Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. It's me, Richard, here. Today we are looking at this question. Let's analyze it and see. It says, what is meant by longitudinal waves? What are they? Okay, longitudinal wave is the type of wave in which the particles of the medium are moving in the same direction as the direction of travel of the wave. This is contrary to what we saw with the transverse. Here, the particles of the medium and the direction of propagation of the wave are in the same direction. Let's put that one down. Then comes the next question. It says that the diagram below shows a longitudinal wave through a spring. Okay. And the question says that identify the regions marked A. Okay. What are those regions marked by A? You have to remember that these regions have low pressure. The spring coils are further apart. So what do you call that one? We call it rarefaction. And the regions or areas marked by B. B represents region where the coils are closer together. And those regions are called compressions. So that is that. Then comes the next question. It says, what is meant by compressions of longitudinal waves? So what are they? So these are regions in longitudinal wave where the particles are closest together. Okay, let's put that one down. Then comes the next question. It says, what are rarefactions of longitudinal wave? Okay, what are they? Okay, these are regions in longitudinal waves where the particles are farthest apart. Okay, let's put that one down. Okay, then comes the next question. It says that in the diagram below, the time taken for a wave to move from point A to point B is 0.2 seconds. Okay, and it says calculate the velocity of the wave. So when you analyze this diagram, there's something you see. First of all, let us analyze this distance given. The distance is from compression, actually mid of the compression, to the mid of the compression of the next one. And what do we say? Remember we said that the distance between two successive points which are in phase is wavelength. So this point is in phase with this one and they are next to each other. This is the adjacent one. So that distance is wavelength. So we know the wavelength. and it is a 12 centimeter. We can convert it to meters by dividing with 100 to give you 0.12 meters. Okay, then what is next? Then we have to know that 0.2 is the time to move the wavelength, and the time to move the wavelength is labeled as period. So we know the period of this wave, and period is denoted by t and is 0.2 seconds. Okay, so what do we do from here? We can use any equation of our choice. We can use velocity is equal to lambda over t. And what is the lambda? What is the wavelength? The wavelength is 0.12 divided by the period, which is 0.2. What you get there will be the wavelength. Let's get it. What will be the speed or the velocity? Let's get it. So that is what we get. Or you can say V is equal to F lambda. So what is F? It requires you to know that F is the reciprocal of T. So what are you going to have here? It's going to be 1 over T, and T is 0.2 times lambda, which is the wavelength, which is going to be 0.12. Still, it's going to take you back to 0.12 over 0.2, giving you 0.6 meters per second. Okay, that is that. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. See you next time. Don't forget to subscribe. Don't forget to like, and also to refer our channels to the person who's important to you, because we believe it's very useful. See you next time. Bye bye.